Have you ever been faced with a pile of nuts and bolts and not known what fits what? Like here. This nut and bolt look as if they would fit. But they won't. Let's try these two. They fit a little too well. What's wrong? I'll let you in on a secret. What we have here is a pile of nuts and bolts, yes. But some of these are sized in customary measurements, inches, while the others are in metrics. And while they look as if they might fit one another, very minor differences in the dimensions of hardware used in the inch system and the metric system prevent you from interchanging them. Like here. These all look the same size, but some are inch and some are metric. Since we live in a nut and bolt world, we have designed this program to acquaint you with a wave of the future, the metric system. Examine the hardware enclosed with this program and attempt to fit the pieces together. If you are unsure about a nut or bolt, use the nut and bolt gauge to determine its size. Here, and only here, the difference between customary and metric hardware is made evident by color. We'll let you decide which is which. The program will stop here while you work with the hardware. Press the restart button when you're ready to continue. Did you figure it out? The customary hardware is silver-colored, and the metric hardware is yellow-colored. Why should you be concerned about the switch to metrics? As you probably know, the United States is the last major nation that still does not use the metric system in all areas of life. Great Britain converted some years back, and that says something right there, for our inch-mile-gallon system was derived solely from the English. Mexico has been metric since the system began, and Canada, the country most like us, is converting rapidly to metrics. That leaves the U.S., but not for long. In fact, the only difference between the U.S. and Canada is that while Canada did most of the conversion in one fell swoop, the U.S. is taking a slower approach, doing it gradually, starting a few years ago and probably continuing through the end of the century. So, ready or not, the metric system is coming. But wait. You've probably noticed that metrics are already in use around us. Foreign cars are, of course, built to metric specifications, with metric components. Many newer U.S. cars also have metric components, so the metric world is certainly here to stay. Closer to home, Deere & Company is gradually phasing into metric components and specifications. New moldboard plows are almost entirely metric, and the width of cut of these plow bottoms is now given in metric units. 400 millimeters, instead of 16 inches, for example. Many other Deere products have some metric components or hardware, and more metric design products are sure to follow. The question on your mind must be, why metrics? For one thing, metrics is a much simpler system in the relationship of measurements to one another. It is based on multiples of 10, like our monetary system. 10 pennies to a dime, 10 dimes to a dollar, and so on. On the surface, metrics is certainly a lot simpler than our system, where we have 12 inches to the foot, 5,280 feet to the mile, 4 quarts to a gallon, and so forth. The base of all metric measurement is the meter, a little more than a yard, or just over 39 1/3 inches. The meter has its own scientific base. In 1790, when the metric system was set up, it was officially described as being 1/10,000,000th the distance between the equator and the North Pole. In 1960, the meter was redefined more scientifically to match the wavelengths of a krypton gas. Don't concern yourself with this, however. The convenient thing about the metric system is the fact that all metric units of measurement, length, weight, volume, and temperature, are based on the same principle and are all interrelated. For example, as officially defined, 1 cubic centimeter of water at 4 degrees Celsius, you may have called it centigrade, occupies a volume space of precisely 1 milliliter and weighs exactly 1 gram. As you see, users of metric can easily convert from length to weight to volume and back again, and do it all in terms of tens. Now, before we go any further, let's take a moment and explain all these prefixes. And again, logic based on tens is the basis for all. First, the prefixes on top, deca through mega, are Greek in origin, while the fractions at the bottom, deci through milla, are Latin in origin. Take a moment and study these, and you'll see how this total relationship begins to take place. For example, you've certainly heard the term kilogram for 1,000 grams, or centimeter, which is 1/100th of a meter. We'll stop the program here so you can study these prefixes and what they mean. Push the restart button when you're ready to proceed. Now, knowing those relationships, you can go back to the base of metric relationships and easily figure out that a liter, or 1,000 milliliters of water, takes up 1,000 cubic centimeters of space and weighs 1,000 grams, or 1 kilogram. Now, let's take a look at all three metric forms of measurement, length, volume, and weight, and see how they relate or will relate to our everyday lives. We'll begin with length, the meter. We've already mentioned millimeters in terms of width of cut of our new plows, so let's go on from there. As we pointed out earlier, a meter is a little longer than a yard, just over 39 1/3 inches. You've probably heard the term kilometer, 1,000 meters, which is written as a small km. Long distances are usually expressed in terms of kilometers, 1 kilometer being about 6/10 of a mile. In Canada, for example, the open highway speed limit is 100 kilometers per hour, about 63 miles per hour. At the other end of the scale, we find the smallest unit of measurement, the millimeter, written as you see here. Extremely small dimensions are measured as fractions of a millimeter, generally 1/100th of a millimeter. How does the millimeter relate to our lives already? Well, to answer that, let's make a phone call. That dime you use to place the call is approximately 1 millimeter thick. And the buttons of a touch-tone phone are 1 centimeter wide. You should also know that there are approximately 25 millimeters, or 2.5 centimeters to an inch. So to convert that width of cut measurement, for example, you simply divide the millimeters by 25 to get inches, or multiply inches by 25 to get millimeters. You may have heard the term hectare. A hectare is the metric version of our acre, the basis of land measurement. Now, knowing that the prefix hect means 100, you should know that 1 hectare is 100 meters by 100 meters, or 10,000 square meters, about 2.5 acres. Finally, here are some metric measurements for area as you would write them. At top is the symbol for square meters, what would be used in the measurement of a room, for example. In the center is the symbol for hectare, which we just discussed. At bottom is the symbol for square kilometers, the measurement that might be used for large amounts of land area, a state or province, for example. Now let's look at metric measurements of volume. Here, the base unit of measurement is the liter, written as a large L in North America. In other areas of the world, it is written with a small l. Note that the liter is the closest to its U.S. equivalent, the quart. 1 liter equals 1.057 quarts. Liter measurements are becoming common in the U.S. already. Some soft drinks, for example, are now being sold in liter and 2-liter bottles. Many other products still carried in our familiar quart, pint, and gallon sizes have their metric equivalents printed on the labels. And many service stations are starting to sell gasoline by the liter. In volume measurement, perhaps more so than any other, the conversion to metrics has most taken hold. Small volume measurements are expressed in milliliters, written as ml. Remember that 1 milliliter takes up the same space as a cubic centimeter. Now we come to the metric unit of weight. Here, the basic unit of measurement is the gram. 2 paper clips weigh approximately 1 gram. The gram is a very small and precise unit of measurement. It takes 29 grams to make an ounce. For that reason, our scientific professions have measured in grams for years. Chemicals and medicines are commonly measured in grams. And for even smaller amounts, there is the milligram, 1/1000th of a gram. That can be even more common. Perhaps you take a 500 milligram vitamin pill each morning. Our own profession, farming, also uses gram weight measurement as a matter of course. Delivery systems on grain drills and planters are calibrated using grams for precise seed distribution. This can be converted to pounds per acre or plants per acre for optimum yields. In the future, once the metric conversion is complete, tables in operators' manuals will be expressed also in metric terms, kilograms per hectare. Most metric weights are expressed in kilograms. 1 kilogram equals about 2.2 pounds. In metric countries, our familiar 10-pound bag of sugar would come in a 5-kilogram bag, actually about 11 pounds. By the way, people who use metrics commonly use just the term kilo when talking about kilograms. 100 kilos of flour, for example. It's not the proper way, but you may hear it. Much larger weights are expressed in a familiar term, tons. However, it's a metric ton. A metric ton is 1,000 kilograms and equals 2,200 pounds. A convenient thing about metrics is that you won't have to worry anymore about pounds per bushel when measuring seed. It will be expressed as kilograms, period. There are no such things as bushels, pecks, and so forth in metrics. Now, with all this talk about converting from our system of measurement to metric, 1 kilogram equals 2.2 pounds, a liter is approximately 1 quart, 25 millimeters to the inch, and so forth, there is one highly important area where such conversions will not be possible. Hardware. That's right. The very nuts and bolts you work with every day. Inch hardware is inch hardware and metric is metric, and that's that. With few exceptions, as our little game at the beginning of this program showed, one cannot be substituted for the other. Here's what can happen when you try to force a metric nut on an inch bolt, or vice versa. They just won't fit. Here, we have a 3/8 inch bolt alongside a metric 10 millimeter, and a 7/16 inch bolt beside a 12 millimeter. They look like they would fit, but they won't. For the time being, and that means probably until the end of this century, tools and dimensions will be expressed in both metrics and their inch equivalents in pre-delivery instructions, operators' manuals, technical manuals, and parts catalogs. When in doubt, any doubt, refer to the proper manual. Whatever, don't risk damaging the equipment or injuring yourself. Always remember, however, that hardware dimensions cannot be converted. They are either inch or metric. The question will come up, can I use inch nuts and bolts where metric is called for? The answer, for through holes, yes, if the metric size specified is temporarily not available. Replace the bolt with one of the proper specifications as soon as possible. But do not, in any event, try to force a metric bolt into a threaded hole or vice versa. You could strip the bolt, or worse, maybe even crack a casting or reduce the holding torque. Such a case is not only damaging, it can also be hazardous and expensive. This metric-to-metric rule also applies to hoses, pipes, and other connectors. Where metric parts are used or specified, use only a metric replacement part. Over the years, as the metric conversion takes place, there will still be an ample supply of inch parts and hardware to cover older models. All John Deere machines, for instance, will continue to carry inch specifications for a long time after their metric. Implements, because they generally have shorter lifespans, will probably be phased into metric somewhat sooner. Of course, selected industries will continue to use common measurements for the indefinite future. The building industry, for example, just because buildings last for centuries. But here at Deere & Company, the word is, welcome to the new world of metrics. Try it, and in due course, you'll find that you like it.